Okay, guys, I will be talking about Prometheus at scale. Scale means, first of all, like maybe traffic, like lots of traffic, lots of something like that eventually help us to validate like this system will hold up or not. Also, from scale, there is one more important thing, that is scaling. So, system that you design should be scalable. And what I will talk about is more on past experience, not the current experience. So, the system I worked at 2018. That time, lot of things were new, lot of things were not stable in terms of the community. Prometheus. I will talk about Thanos. Thanos was in beta. So there were lots of unknowns when we did this. I just get to know like the system is scalable because it's still running like now like to 2024. So it means like the things which I will talk about is like these were built for scale as well as scalable. So moving forward. Hi, I'm Abhishek. I'm currently working as DOE, Director of Syfe. Today I will talk about architecture program we did back in 2018. So yeah, I was I will be talking about how we migrate our observability from a enterprise to a in-house monitoring system, which eventually helps saves millions of USD, and eventually it helps us in a lot of other things like things which were not offered by the enterprise tools at that time. Right. Cool. Let's talk about the scale first. So we were having around 25,000 nodes or endpoints that we can that were exporting the metrics. Data ingestion was 300 billion per minute. We calculate, I think, service scrap, sample per scrap. So this was the traffic that I think that time. Retention we have to keep is like 30 days because the enterprise solution was offering 30 days maximum. But then we go extra mile. Let's say some services will keep 60 days also. And cost, like enterprise solution that we are talking about is Datadog. So cost that time was 6 million per year. I'm talking about 2018. So now I have listed down some current pricing. If you can see, like I will talking about more on APM infrastructure monitoring, not the logging part. So right now APM range 31 USD per machine, infrastructure $15 per machine. So if I have to calculate with this number, so it will something comes out like USD 14 millions per year. So that's a very huge number in terms of some companies. Most of the time it's the Series A or Series B funding for most of the company. So this part is pending. So I will talk about Prometheus here. So before that, I will thanks Abhinav. So he said the contextual lot of things. What is metrics? What are logs? What are the spans? What are the structure log? What is an structure log? So I will not talk about those things, but I will talk about Prometheus. So Prometheus, what it is. So Prometheus is built for something which is metric-based monitoring and rating stack. It used for instrumentation, metric collection and storage, querying, alerting, dashboarding for all level of stack. What it is not for? It is not for logging. It is not for tracing. Tracing, we talked about Elasticsearch. So Elasticsearch is one of the built for tracing. Logging is also Elasticsearch. So Prometheus is not for logging, event collection or tracing. Automatic anomaly detection, scalable or durable storage. I will come back on this part. Automatic horizontal scaling and user authorization management. So this is not built for these things. So I will talk about basic architecture of Prometheus. So might be like people, folks which are sitting back the seat, they have to come forward to see the architecture. So this is the most technical slide in my talk. We will talk about this in detail. So this is something I copy paste from Prometheus website only. So this is the basic Prometheus architecture. So we will talk each and every component one by one. So let's start from Prometheus server. So basically, Prometheus server comes with time series database, which is actually hold the data, uh, and it actually dump data in HDD or SSD. So as we know what is whole, what is database concept. So these also work on that concept. So it get the data dump into the HDD, which is stored into the same node which where the Prometheus server is running. It also have a HTTP server which we can use to query the data, uh, or yes, and there is a retrieval endpoint which actually helps into the retrieval part. So basically, Prometheus is a pull-based system. So pull-based system is like before this, there was lots of push-based system. Push-based system was like you expose some endpoints. There was a central server also, and you are sending a lot of metrics to it, that system. But here, to make it scalable, Prometheus come up with the pull-based metrics, where now it is actually finding the endpoints that where like we have to go the service discovery, file SD and Kubernetes. It find the service which they have to fetch, and from there it will directly pull the metrics, will again write to the THDB, and then eventually write to the HDD or SSD. But if traditional system basically might have some, I think, short-lived jobs which cannot expose some endpoints, and there you need to send metrics and you push metrics. So they have something called push gateway for this. You can send data to push gateway, and Prometheus eventually can pull data again back to the from push gateway. And I think there are some exporters. So there is a concept of exporters. Exporters are something which are running into the node, and they actually helps to fetch the data, and then they host their data on certain endpoints that actually Prometheus discover by using Kubernetes service discovery or file SD. So think if you are coming from the background where you know nodes, EC2, so you will have to use this file SD. If you are coming from a EKS background, Kubernetes background, so service discovery is something that you can use. So this is all to get the metrics and dump into the HDD. And there is something called alert manager. So alert manager is a component which is used to send alerts. So it runs on queries over it. On the basis you define like at what level, what metrics you need to send alerts. So alert manager does have good integration with PagerDuty, email, Slack, blah blah blah. So you can use alert manager to send the alerts. And there is something called PromQL. So PromQL is a query language for Prometheus. So whatever you are writing into the Prometheus, if you have to query that, you should use the PromQL. And you can use some simple Prometheus web UI, Grafana, or some API clients to run the PromQL and see your data. So this is the basic Prometheus architecture. And so far, if you have any question to answer, but this is, I think, yeah, Prometheus. So I would say yes, this is simple. Like, what's the problem here? Yes. Loud.
Multiple nodes, what is the exact scenario in the production environment?
Yeah, your question is WAL. So it's I will cover in the next.
Okay, one more question. Like it's a very basic question. I have open telemetry and Prometheus both. So what are the advantages of using open telemetry over Prometheus? And what should we ideally use in production environment? Like as a developer or as a DevOps engineer?
So you are using open telemetry, right? So if you had followed up enough, so open telemetry and a lot of things, right? But here we cannot collect traces and logs, right? But for metrics, we can still use Prometheus, right? So Prometheus, you can think of as a database rather than Hotel is a library which exposes the data. Prometheus helps us to dump that data right into the databases, THDB, like databases THDB. So and eventually you can same stack and use the same ecosystem to query the data like from the PromQL or Grafana and build your dashboards. So you can use both if you want to. So I think that's it. So going over any other question, guys? Anyone? So yeah, it was simple. So, but there were some problems when we implement that. So we we face some issues. First question, like someone here we asked, like it has a single server limitation. So Prometheus is designed as a single node system, which can become a bottleneck when dealing with a high cardinality. I will come to the cardinality, but a large scale environment will not work because uh, you see it was attached to a single HDD. So coming back to this diagram, so Prometheus server is attached to the HDD. HDD have this basic problem. It is not scalable. Even though you scale it, you have to do vertical scaling, and again, at some point of time, you will run out the IO. Still required to write the data or read the data. And if you are writing or reading at a very high scale, you will run out or you will hit some limitations. So this is the first problem. Second, I also discuss storage. So local storage of Prometheus can be limiting factor for a long-term storage and high frequency data points. Yes, cardinality. So what is cardinality? Cardinality is large number of unique label combinations. So basically how it tries some keys and then values. If your data, metric data have lots of labels, it will have a lot of high cardinality. More labels, more cardinality. So there should be less number of unique labels to reduce the cardinality. More cardinality will eventually lead to increased memory usage and decreased performance. And then query performance also will be slow because now you have to fetch a lot of files because at the end it's writing to the SDD, there will be segments. In segments, you have to find out the labels, join them, return to them. So there will be required more CPU, more memory, and that will lead to the query performance issues. So we talk about the scalability issues, we talk about high cardinality performance issues, and these are the two basic things you will run face first when you will running the Prometheus. There are more, some configuration management and operation have overhead. So configuration management, like when you running at a scale, like something like 20,000, 25,000 nodes, you have to manage those IPs, where to collect those metrics. You have to make sure that all the configurations are at the right place at right time. And there is operational overhead also, like maintenance and upgrade. So whenever you have to upgrade, you have to handle the scaling problem, troubleshooting. You have to make sure your production is up all the time. You can say like we will have some downtime while doing the upgrades. That's not one. So these are the two more things which we can discuss. But mostly in my talk, I will talk about these two issues: scalability issues and high cardinality. For configuration management and operational overhead, simply for configuration management, we should use a configuration management tool. Right now, there are Ansible, there are some others which we can use, and there are Terraform to manage the infrastructure. And there are operation overhead, it also can be fixed via some automation using Terraform or some other kind of tooling, which can help you maintenance and upgrade using building your blueprint system or different type of pipelines. So next. Let's talk about business. So high availability Prometheus. So basically there was a problem that Prometheus cannot scale a single node. So what you will do? You will create two nodes, right? You will run two Prometheus nodes into two Prometheus servers into different nodes, and you will both will be collecting the data, writing the disk, and yes, your voila, your issue is fixed, but not so early. This architecture also has some problem. First of all, what is written here, when you refresh the data, you will see it changes as metric will be potentially different between the two instances. What it means, let's say I am collecting a metric at 9 a.m. from a one server. Another server is running collecting metric at 9:05 or 9:01. So it will have a different pointer. And when you will query the data, you will see a lot of difference, and it will be visible. So you cannot take a call on that number. Or one more issue here. So basically, if you will see here in this architecture, all of them are collecting from the same targets. Like first server is also collecting from the three targets. Second, you're also collecting from the three targets. And let's say if the targets itself sending a lots of data, means you are facing a high load problem. So same number of load will be hitting to your servers, and at the same time both will be down. So there is no advantage of having two servers with same config. So to fix this problem, what you will do, you will create two servers with different config. For example, you having a one server with 4 gigs of RAM, another server is 8 gigs of RAM. So second node will handle 2x of traffic. That's the assumption, right? And that's what we can do. But again, there are still some problems like refreshing data, blah blah blah, and it may fail. So how to solve those problems? And this is actually what we face while we designing the system. So we eventually think like we can have two nodes, we can shard the data, we can have different file SD points where we will collect different endpoints, because we have to make sure we have to run to the probability like both of the nodes will not go down. So same thing we tried, and it did not work. So there comes Thanos. So Thanos is a set of components that can be composed into a highly available matrix system with unlimited storage capacity, which can be added seamlessly on top of existing Prometheus deployment. What it is, let's understand. So this is the architecture. Basically, we designed using Prometheus. I'm trying to zoom it. Yes. Cool. So basically, you will see a lot of new component. So this is Prometheus, this is Thanos, and there are multiple components, because if you read this slide, it is a set of components. So we will talk about what are those sets, what are those components, and how they can be helpful. So first of all, there are three components. One is Prometheus. Prometheus is storing the data. There is alert manager, which is sending the alerts, and there is a Grafana or some UI where you are running the PROM12 query to see the data. So we have to make sure that all of these components should be scalable. Then we can say our system is scalable. So I will go down by one. So you are a user where you are running a query. So I will come to that part, but let's understand this part. To make use of Thanos, you need to run a sidecar along with your Prometheus, so that it will help us to understand where the data is residing. It will run query on the behalf of running query directly on Prometheus. Instead of that, we will running from the sidecar and will see the data. So there is a query server which is required, which will run the query on the sidecar, and there is something called store gateway, which you actually know where the data is. It holds some metadata configuration, and it can help us to store that data, whatever we are writing here, into the S3 buckets. So S3 bucket I'm writing, but you can think of any other object storage. So this is one of the best capability with the Thanos. You can use use different storage. So because earlier, if you will see, you were writing all the data into the SDD, but if you will have to go unlimited storage, you need some cheaper storage solution, and there I think the object storage is the best solution. So you can use S3 buckets, and in S3 bucket you will write the data. I will talk to compactor in a bit, but there are ruler and there are I think that's it. So these are all the components which you need to run, and all the data is still collecting. So in our case, we were using Telegraph. So it's listed here. So instead of any other exporter, we were using Telegraph, because Telegraph was giving us a lot of simple CPU memory, state matrix or system matrix with a single exporter rather than multiple exporter we have to run. And that's where we were able to scale the Prometheus server. Like if you will see, this is a cluster 1, this is cluster N. So you can run a number of clusters with different config or maybe same config, and now the Prometheus layer is scalable. The problem is the data writing on the layer is different from each of the Prometheus server. So if we were discussing about this problem, like when you will run the query, the two Prometheus server can return two set of data. So one thing Thanos does is deduplication of the data. So if you are getting same set of data, it will deduplicate it and return in the same query. Like when you will see the data, it will not have that kind of problem. So this again Thanos solved, and I will talk about the compactor. So compactor is the another component which do three part: compaction, retention, and deletion. So it reduce the data. So it called downsampling also. But compaction means basically if you are running your collecting your data at every, let's say, 15 seconds, and you are debugging an issue on the production right now. So you might need for a day, or for, let's say, less than a day, you need more metrics, more data points. But over the 6 month time, you don't need that kind of data points. So you can do the downsampling. You can compact the data. So at the end, it will reduce your storage cost. Second is retention and retention. So basically, at the end, you don't want to keep your data for lifetime. So you want to delete some data. So it will figure it out what is the retention for each data points, and it will run the deletion and the retention query. So this is compactor, and now the architecture looks like this. Like once a user want to see the data, it will directly go to the load balancer. And behind the load balancer, we will have multiple Grafana servers. So Grafana also come up with different kind of database where we can have different authorization, authentication in a database, and all of them can hold the same data, in which you will provide another load balancer endpoint, or maybe Thanos query endpoint. It will go and run the query. I think I forgot this one mark, but it will go to the query server. Query server will run the query to the Prometheus server via the sidecar, and it will run the deduplication and actually return back data to the Grafana server and to the back to the user. That's how it works. Store gateway, compactor, these will work individually, so they are not at the query level. And now I will talk about the ruler. So there was another important aspect of Prometheus, was the alerting. So in alerting, Prometheus uses alert manager. So good part of alert manager is alert manager can work into the clustering mode, unlike Prometheus. Prometheus is designed for a single node, but alert manager can run in the clustering mode. So you can have a number of alert manager by default. And if, let's say, one node will be down or one service will be down, it will not break your system. But at the same time, it required the support of deduplication that ruler provides. So you need to, instead of defining all the rules, recording rules is something which we have to create to run the query on the alert manager. So when you define those rules, you don't have to define directly on the, I think, from the Prometheus. You have to define here on the Thanos ruler, and it will do all the deduplication and run those, give that data back to the alert manager. And alert manager, based on the threshold and all the things you will put, it will alert you based on the client you have provided. So this was the, I think, the main architecture that helps us to make it system scalable using Thanos. So any question here before we move to the next slide? Yes.
So when the query has been run on S3 is comparatively slower than the disk. Right? So do we need to mount the storage, or I mean, like, how does it work? I mean, if it directly do the query on the S3 would definitely be slower than the RAM or the disk, right? So either you or I mean, how does that?
Right. This is a really great question. So first of all, you have to know your customer. So basically, let's say what will happen when you are running a production issue. So mostly you will see latest set of data, right? 1 day, 3 day, 5 day, right? And then at some point of time when you are doing analytics, you need 6 months data, 3 months data, 1 year of data. This is practical, right? So you have to design your system in a way like before you sending the data to S3, you can hold those things here in Prometheus directly into the HDD or SSD. So I can configure it that way, like for 1 day or 2 day, my system would be in my local disk, and after 2 days, I will sync it back to the S3. This is one part. Second part, basically, we using the store gateway, we can have some metadata which we actually know which type of actually different type series database, right? So for each time, there will be different file. When you are running a query, so it knows like which files I need to run this query on, right? So it actually helps us to running the query in parallel when you are running query on S3, and it is not that slow. So you can use parallelism here to run the many query, and over the time you can get the data one by one and plot it on the Grafana and the dashboard. So you can use that. Third is important aspect is how we are running the query. So I will talk about this because running the query is something like, say, if you are running ambiguity, like if you are just asking like, tell me how many nodes are there with without any condition. So it have to fetch all of the data, right? So to make your query faster, basically you need to learn how you have to run the query and how you can optimize that query to get the result faster. So these are the some other important things apart from the architecture that we have to build. One more thing, like there would be some customers which might not be that technical as in this group. They still will run those queries, right? So even though you will tell them like don't run these type of queries, they will still try to see like if your system is actually scalable or not. To test that system, they actually did that kind of work. So you have to make that configuration in that way, like put timeouts into place into the system. So when you are running the query at the query engine, you make sure that there are a timeout in place. For example, if your data is not getting returned into 30 seconds or 60 seconds, don't proceed, right? Just return whatever you have already get. So these are the things you have to, I think, design when you have to optimize for the queries. And yes.
Deduplication happens on which? No, sorry.
Repeat.
We have a Thanos query component there, right?
Right.
So do the deduplication happens on Thanos query itself, or it happens on the below two sidecars which are available? I don't think that it will be able to handle it over there, right?
So yes, so basically sidecar know one data within the same set of clusters, right? It is tied to the each Prometheus server. So it is responsible for handling the data, I think, with the Prometheus server. If I am remembering it correctly, I might be wrong, but it is happening here only, the query engine. So it is running the application, but we can double check later. Right. So question here is like, what is the edit latency after putting these set of components, right? So Thanos have two different protocols when they load. One is gRPC and another is HTTP. So lot of communication when Thanos to Thanos communication happening is always happening at gRPC. And when it is returning, it is actually doing at HTTP layer. So mostly gRPC level does not have that kind of latency. It's almost always in milliseconds, right? So that helps in reducing the latency with edit components. Right.
So that can depend on what factors I wanted to understand. If you're going to a Prometheus, it will get that data in some time in 1 second, it give you data in 3 seconds or something. In that case, have you seen any of these kind of latency issues with this system or not?
Obviously, it would be slower than Prometheus because when you are running directly on a SSD, right, and with a single system, it is directly responsible to returning this. It knows like where the data is reside. It does not have to do the deduplication. It does not have to do some sort of other analytics. So it would be always faster, yes, but it won't. Actually, what we need is not the fastest system here. We need a reliable system here, which can fill our SLO. And our SLO probably in that case would be certain seconds, right, rather than milliseconds. So we were okay with that, I think. So if let's say I will talk about again, these things depends on the query again, what a query you are writing. So if let's say as I mentioned, like if we are keeping one day data into the HDD or SSD, right? So it will eventually be faster than if you are writing a query for a 6 months long data, because now they don't have to go to the S3 layer and fetch the data, give it back to you. So if I will just compare the data returning from the disk, it would be negligible. So it won't be, I think, foreseen, but yes, it will slower than the directly from this. Yes.
So the choice of SC bucket or any of this because of a default compatibility of Thanos, like does that Thanos have a default compatibility with something like S3 API or?
Yes. So the question here is, I think, the storage API. So basically, Thanos or by default Prometheus just exposed different, I think, compatibility client. So basically it's already done. So S3 is just an example here, but if we will right now we will talk about like any other object storage mainstream object storage like from Azure, from Google. So they are all compatible. So as enabling, yes.
Have you tried deploying it on Kubernetes?
Right.
So any difficulties we faced in this architecture?
So as I mentioned earlier, so one thing here, if you will see back to the Prometheus diagram. So one thing is common, like Prometheus server is identical to single node, right? And the only part is getting changed is like how you are discovering your endpoints. Like is it service discovery or is the file HD config? So Prometheus actually does not tie with like the underlying layer. If you are running on the EC2 or in the EKS or ECS or any other component, it does need to reach out the endpoints. And for that, you actually have to work more on the networking layer because you know that there should not be firewall or there should be like allowed ports to reach out to that destination. So first part is service discovery. You need to find all the endpoints which you need to run the data, run the query. And second part is like reach out to those endpoints. And third part is like writing the data into the disk and storage. So I would say there is, I think in terms of complexity, I would say there is none in terms of the Prometheus architecture. So if you know like how the EKS works, so it would be same like as in how you know how the EC2 works.
What about the storage part in the Kubernetes cluster?
So it would be same again. So it depends like because you still need some storage to write some sort of data to be system make fast, right? So you can attach those stateful set into the EKS if I know, and right. I think then the architecture will be same.
If you are doing it for the large companies, they have large data, so you will be mounting an EFS volume or what?
So EFS won't work, may work, but won't work. First of all, why I will require EFS? Because at the time I don't need many read at the same time, right? I still need one write, one read from a single Prometheus cluster. So I won't go for a that kind of solution, which will add more latency. So I will still go with the volume attached volume. And if I have to make it fastest, right? So rather than I am attaching a EBS over it, I will go for a instance storage. So every time I will attach in storage because at the time I had already made it scalable, like because I am dumping same set of metrics from a different nodes. I have already run the reduplication. So I won't want that queries to be done fastest with the same set of I think things. So I would go for a instance storage so that will give them fastest result when I'm running the in terms of the I think Kubernetes.
Thank you so much.
This one?
Like the slide, like in which like we have why hadn't we like set up the fault tolerance or update tolerance of the server, the Prometheus server to different configuration. If the purpose is to like create a replica of the same, so why we hadn't like selected the like fault tolerance or update tolerance in this, like instead of configuring two different kind of servers.
Right. So question here is like let's say why this architecture does not work. First of all, right, it should have worked. So that I think written here like still we need to have the deduplication of the data that is by default Prometheus does not provide. Second part is again here the cost will be higher because if I talk about the load, let's say underlying targets are exposing some metrics. My system is let's say built for 100K metrics per minute. At this point, I am getting 10,000 K metrics, right? So both of the system will fail until unless one node is at a higher side than another node, right? So to make it more scalable, I have to have a one node at a higher end, and then there would be a lot of configs which I have to put. So eventually, we are doing same thing. We are having the multiple Prometheus servers running, exposing almost same targets. But now we have to define which Prometheus server will get data from which target. It won't be the same targets. So that I think part of configuration management here. So basically there were a lot of configs you have to manage, and to make it, you need a configuration management system so that you don't end up like a failure where there are multiple nodes running on the same target. So blah, blah. So actually we are doing the same thing with Thanos, but still we need deduplication of it. That's why we run Thanos query.
Thank you.
Any more question? No. So seems costly. Like what we did earlier, we were running a single this single Prometheus server. So it was cheaper, faster. We make it complicated. We've done these many components via Thanos. So it should have been costly. So that's calculate. So basically, we use these components, Thanos, Prometheus, Griffon object, and ELB. In some cases, I'm just calculating on the compute here. So basically, RAM requirement for 3 million per minute metrics for 60 days retention, it was around 7,000 GB. Storage requirement was 46 GB, and I think we calculate the cost of a gravity instances because they are faster. So it was 36.2. If let's say we are going for 1 year upfront in AWS, and there is S3 cost, I assuming like there are 10,000 read write code per GB, so it's 0.08. So we calculate it, and at the end, the final cost comes down to this 297,560 per year. Cool. So let's talk about saving. So we were running 6 million at that time for this kind of same metric collection, and eventually I will talk about like the saving. It was 95%. So we were saving around this percentage after eventually moving all the data from Datadog for 8 metrics and to our own Prometheus server. I'm also assuming this is running into our internal server, so we still save lots of net cost also, but that is not counting here. So this is just the compute cost and memory cost. It's mostly memory intensive, Prometheus, not the CPU intensive. So you have to go for a high memory. So that's why I think I talk about memory here for the metrics rather than CPU. So other important points which I will talk. So avoid unnecessary labels and metrics. So minimize the use of labels because that will lead to the cardability. And having that large number of unique values such as timestamps, user ID, session ID, if possible, try to combine them. Also drive excessive metrics for limit metric collection mostly. So I remember one instance, like at one point of time, our cluster was working fine, but fine day, evening, we were debugging and it was not working. So we see like what happened, like it should be scalable, right? So we told our manager that it is scalable, it won't die, but it died. So we get to know like eventually there was a deployment in a service, backend service, and it now exposing let's say 100 of its metrics which it should have. So this is something like one important point, like if possible, try to limit like per host or node collection metrics based on your scale or based on your architecture, so that you don't end up with that problem. One bad actor should not fail your overall ecosystem. So that's I think the learning. Limit label values. I think we talk about labels, but label values also. We should use something called URL pattern rather than exact URL. We should patterns or endpoints. Common set of labels values rather than different set of label values. How much you will minimize, it will eventually will saving in terms of storage as well as in query engine when you will run the queries. Then aggregate metrics. So basically you can also do the aggregated query. So aggregated query means by default when you are writing data onto the disk, you write data on the basis of aggregated metrics. So that you also can also run at the query level on the storage layer where actually for example, if I am writing 5 different status code in different metric form, rather than I just want to run calculation, like just tell me like what is the 5xx total number at this time of frame, and just write that single matrix into the storage rather than having all the data points for n number of minutes for each host into the system. So you can use those aggregated rule to make it more scalable. Downsampling, we talk about downsampling. So for historical data, you don't need that kind of high samples. So you need to reduce sample by doing the downsampling. Optimize your PromQL query. We talked about this. and there is something called query caching. So Thanos also does provide support of caching. So you can have some system in place which actually have your data cache at a certain time, which is being regularly used. So you can use some Redis or any other data caching database to optimize it. So I will highly advise this using the caching layer. And next is monitoring and alerting. Set up alerts to notify when you are running the high priority issue, so you don't end up running the same issue that we have. So these are all important. So meet the team. So basically these were the folks which build their system. So one obviously it was me, and there was some other. So this is graduate seats. So Ram. So we both only work on this particular system for a month, and then we'll eventually be saving the cost. Yep, I think that's it. Question and answer.
Something regarding the S3 query. So
because he's gonna, I mean, like the application is gonna make API calls, because you said that it's based on open API calls. Now API calls also have the cost associated with them. Now if, just like you said, that if there's no specific condition upon which the query has been made, the query will make a huge lot of transactions inside the S3. So it could happen also, but is there any way or any best practice which you have followed to minimize the amount of transactions to the S3 API calls? Because
Caching.
cache.
So first of all, you should not have that number of queries for a past data. So that is by default, I think, bad practice, because there is no, I think, silver bullet. Basically, you have to think based on your customer again. So if I am creating a dashboard on Grafana, and I created like default time on the top of it, I make it like 30 days. So whenever someone is loading the dashboard, what will happen? They will running the queries for the 30 days. Second part, when you are designing your Grafana dashboard and you don't use what it called like tabs, there is some name of it, but if you by default all the dashboards are open, so you will open the dashboard, you give the link to someone, they will open the dashboard, it will run a number of queries at the same time. By default, there should be no query. When someone will open the dashboard, there would be zero query. Someone will expand a tab, it will run the query. So that's how you design your dashboard. So it is just not the Prometheus or the backend system. It's how you actually think based on your customers or the needs, and then eventually create that kind of dashboard. So I think this one is easy, what I told. The second, I think, critical part is how we build your dashboard. So that will eventually help saving in the cost as well as I think. Any more question? Thank you.